A little bit about Timeseries data and NoSQL data stores. Yay! Finally, I hear you all thinking. Maybe the wrong conference, I don't know. So I'm Martin. I work at the company called Open Sensors. And I've been doing Clojure professionally for almost 4 years now. So it's quite a lot. And Open Sensors is actually my second IoT startup using a Clojure stack. So there you go. We keep trying. Yeah, so what is Open Sensors, quickly? We are an IoT as a service company. So we provide message brokerage for devices to talk to other devices. You can, manage your devices, so device management. We are topic-based, so you can manage the topics that devices publish and subscribe to. You can manage your users and orgs and all that stuff. We're quite early still. I mean, we've been around for a couple of years, but we on the main cluster, we process something like 100 messages per second, roughly, at the current rate. So it's not super big and it's not super small. It's kind of in the middle. Yeah. So you can, up and above the CRUD stuff that I mentioned, you can also use the site to watch live information, so like the live messages as they come in on these topics. You can see logs of them, and you can also graph them. Yep. We also offer a REST API, so everything you can do in the UI, you can also programmatically do all the CRUD operations. We actually dog food this API. So the actual UI that we've written is actually using the API itself. In addition to the CRUD operations, there is also endpoints to extract historical messages. So if the live information is not good enough, you actually want to see what came, the last week or last month, you can use the REST API to kind of download all that stuff. And downloading this historical data is kind of the core of my talk, because this is where it kind of comes into how we store and query this time series data. There is also, finally, I want to mention that there is also a real-time REST API for the real-time events, if you don't want to look back in time, and that's what we use to do the graphs and live feeds on the site. And that's using the server-sent events thing that some of you might know what it is, like event source in JavaScript, which is really great, and I think a lot more people should use, because pros and cons versus WebSockets there, in my experience, weighs more to SSE. Okay, so that's kind of the bread and butter of what an IoT service does. Everybody does this. So what's our value add? Like, how do we pivot? So everybody in the IoT world is talking about like added intelligence upon all this data, because there's a lot of sensors sending a lot of data all the time, and just looking at the raw data stream is not very useful. How do you actually make sense of all this data? So some of the stuff we do, so here is like an imaginary product that we're working on at the moment. So we've done a lot of work on air quality recently, like the Heathrow. I don't know if you read about in the paper a few months back about there was some worrying signs about Heathrow air pollution, etc., and it was actually loosely based on Open Sensors, because we are collecting a lot of open air quality data and try to provide that to researchers to do analysis on the actual state of the air quality, not just like the spin from people with vested interests. So here's an interesting kind of slideware that we have. So let's say you commute on a bike to work every day, right? And you read about air quality, so you're a bit worried about, actually, I probably don't want to bike into work every day, because it'd probably do more harm than good, because I'm breathing a lot of toxic poison here, right? So what you could do now is you could draw your commute on a map. So, somewhere in this sausage, I will bike to work every day. And then we will collect, the air quality data for you, for that, and we will kind of come up with one final number. Is it red or green? So you put this traffic light next to your bike, in the living room, and in the morning, if it's green, okay. If it's red, okay, I need to take the bus and put my mask on. So this is what I mean, right? So you have thousands and thousands and thousands of data, like you don't want to wake up in the morning and scroll through and try to work out if it's safe. The whole point is kind of boiling it down to like a binary yes/no that's like immediately usable for people. So this is kind of the core of what we're trying to do, and we're trying to work with, because there's a lot of open data out there, a lot of open sensors, you know, hint. So making that available and collecting that is kind of what we're trying to do. Okay. So that was the intro. So this is our stack. Going technical now. So we're a Clojure shop. Clojure in the front end, in the back end. Here's like some highlights and keywords. If you saw Chris's talk yesterday about how to do Elm in ClojureScript, this is what we're doing. Chris helped us to set all that up. So it's reagent, BD for routing. We're using Kio for templating. So instead of using reagents built in kind of what's it called, hiccup stuff, we actually enlive in stuff, enlive style into real HTML files. Our friends that does all the kind of layout really likes that. On the back end, there's a couple of services. There's the website, which is a Ring app. There is the different APIs I talked about, which we are using Pedestal. Big ups for Pedestal is awesome. I think my friend Frank will talk about that more this afternoon. We're using Swagger, as you might have seen. And then the final piece is the MQTT broker, where we use Netty, and we use something called Reactor. That's kind of cool as well. I think a lot of Clojure people do the mistake of going straight to core async when they want to do like in-process pub/sub. But Reactor is actually something that can do a lot of the hard bits for you, and in my experience, clean up a lot of core async code. So give that a look if you're interested in that kind of space. Database-wise, you know, SQL, Elasticsearch, Cassandra. We use BD. This is like an internal joke. Don't worry, I want to apologize for it, but those in the audience who get it. So let's look at time series data. So this is what it looked like. It's like a big log of all the devices just publishing data. So we have topics, we have devices, we have users, and like a timestamp. And when we want to extract this historical data, right, the typical time series query we do has two kind of components to it. You want to filter out, you want to do a filter on the timestamp. So I'm looking like yesterday or a week ago, or like you have a window of time you're interested in. And then you also have a filter, right? You want to filter on a topic, or on the device, or on a user, right? So this is kind of the core two components of the kind of bread and butter query we do all the time when people access the historical data. So that's fine, but the stuff I talked about, we actually want to do quite a bit more. So just this kind of filtering thing is not really enough. We really want to do like Gero queries that I talked about. So you want to, you know, pick out stuff in a polygon. We also want to do aggregations. So this is kind of roll-ups of the data. So like monthly averages or hourly averages. We want to do some kind of, we can base some kind of rate limiting on this roll-ups if you want to. We also want to do a lot of ad hoc queries for like reports and exploration, right? We talked to a journalist about the Heathrow project, and he said, oh yeah, but what about this? And we want to be able to kind of put a query together and you get some numbers out, right? Another thing we're doing as well is triggers. So you can imagine a temperature sensor. If it's been outside an agreed window for 5 minutes, we want to catch that somehow. So the normal time series queries are great, but we want to do a lot more with it. So how do we do that? So let's look at where we were like time back. So we were using Cassandra to store the time series data. It's great. And we are using Cassandra to do the historical queries, like the time filter and the time window and the kind of device, topic, or user ID filter. So how do you actually do this in Cassandra? Well, what you have to do, you know, best practice is actually to have one table per filter. So if you want to do messages by topic, you have a table called that, and then you have a messages by device table, or column families, I guess is the correct word. So you end up creating basically these tables for every possible query you want to run. And I guess all of us here understand that that's probably not that great, right? because you have to store the payloads, for instance, in all these tables. So the explosion of storage is not great, and it gives you very little flexibility. We can't really do any of these exploratory queries we actually want to do. So we have to solve this somehow. This is not really going to do it for us. Okay, that's great. So let's climb up into the hammock and have a little think about this and find the optimal solution. Well, unfortunately, in the real world, we couldn't climb up in the hammock because at the same time, our backend was basically on fire. Because Cassandra was blowing up all the time. So we had a lot. So Cassandra has this reputation for being very stable and great, but that was not our experience at all. It was actually terrible. That could be our fault. I mean, we had some Cassandra people look at our setup, and nothing is totally wrong with it, but still, we had a lot of issues with it. So we're running on AWS, so we have a dynamic infrastructure. If you know the AWS, they take the liberty to kill off your nodes whenever they want to, because of reasons. And then you want to bring up a new node, and it needs to join the cluster, and that didn't really work for us, because when the new node come up and joined the cluster, the other nodes in the cluster got so busy they forgot to answer the keep alives, so the entire cluster was dead. And they also went into GC hell, so everything they were doing in the logs was just GC, 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 GC. And we're seeing all kinds of issues here. So joining was hard, finding the right heap, giving it more heap didn't really work, giving it more CPU kind of worked, but then your cluster is now so expensive, so it makes no sense anymore. And we also, we did all kinds of mistakes, like too small heap, too big heap. We were on burstable instances. This is now deep into AWS world. Don't use burstable instances for Cassandra, just don't. So so we were trying to get all these goodies we wanted, but we also had like I said, a backend on fire. So how do we get out of this? So one way to do it is you vent your frustration on Hipshot, which feels great for a while, but it doesn't really solve the problem. So this is the conundrum, right? So how do we kind of solve the operational issues we're having and actually give us all these query capabilities that we want? And can we do it at one go? So I think we can, and the answer was already running in our cluster, and that was this other data store that we were barely using. That's actually really good at doing searches. It's in the name, and it's boom, written by this awesome guy. And this is how we felt when it dawned on us. Oh my God, we can use Elasticsearch. So how do we do that then? So it's kind of sitting in front of us this whole time. And how do we do this? So we changed the way we store our time series data in Cassandra. So instead of having one table per every possible query, we just have a blobs table where we just store the meta information and the payload somewhere here, right? So there's really, the only query you can really do against this is just, okay, given a UID, give me the payload or give me the metadata. So we can't really run any meaningful queries against this except just putting data in and extracting data out. All right? And then we also store some other interesting information in Elasticsearch. And the key point here is the ID here is the same as the actual blob in Cassandra. So what this gives us now is we actually, so when we want to do one of these time series queries, we do this search in Elasticsearch. We get back a bag of UIDs that we then go to Cassandra and fetch, right? And so that's great. So that kind of solved that problem. And it also gave us, I don't know how much experience you have with Elasticsearch, but you get the full flexibility that I talked about as well. You can do now any kind of ad hoc queries that you want, right? It's more like a REPL experience when you want to do searches. Elasticsearch is also really good at, this sounds like an ES pitch, really is, I guess. But you can do the roll-ups I talked about. You can do the triggers with percolators. So it's basically everything we want from that. Okay. So the solution, like I said, you run the queries in ES, and you do like a multiget from Cassandra to actually get the payloads out, right? And that is, yeah, that was the idea. And then you use ES for all the other stuff. So here's those geo-search, ad hoc queries, and everything I said. And another really nice benefit of this is that Elasticsearch has like a data-driven query syntax. So it's all a JSON document. It's not some kind of SQL or strings splashing or anything. And this is really great from Clojure because when you're building up this query, this is how a time series filter would look, right? So here's like some search criteria. We're looking for this topic, and we're looking in this date range, right? And there's another little flag, but we're only going to look at for stuff that we actually persisted. And the beauty of this is now you can use all your Clojure friends, right, to build these queries. You know, map and mapcat and concat and keep and filter and all this. These are your friends now, so you can do that in your code, and you can do it in the REPL as well. It's really nice. So did it work then? Well, so here's some Cassandra CPU usage. So this is what happens. So this is kind of our base load when not many are running queries. But then when some people started asking Cassandra questions, it kind of killed itself. So when it's above the red line, the node is now so busy that the other nodes in the cluster thinks it's gone. And this is kind of when we deployed the new world, and then it's kind of flatlined since then. So Kirk disappeared from Hipshot, and it was kind of great. Okay, so, you know, the cynical person in you thinks, well, this is a bit too great, right? We must have missed something. So, okay, we put all our eggs in the Elasticsearch basket. We must have, you know, done some stupid things. So what does Kyle think about Cassandra or Elasticsearch? Well, not that great, actually. He's written about it twice, and, you know, this is as sarcastic as it gets, I guess. You know, every time has been a tire fire. So Elasticsearch is definitely not written to be a storage where you should store your data. It's optimized for search. And, you know, they made some design decisions that, you know, if some data gets missing, meh. Whereas, you know, obviously Cassandra's written the other way. So is there any way we can mitigate that? Well, I'll come to that. Cassandra, I mean, ES itself, so we moved a lot of work from Cassandra over to Elasticsearch, and obviously, what are the operational issues with ES? A lot less we found, you know, this is one data point. One thing is that you want to give ES a lot of heap. So this is what happens, you know, when you kind of double the heap in Elasticsearch, because it does a lot of in-memory caching, etc. So give it plenty of heap. I was saying, yeah. So how do you mitigate the problem that Cassandra or Elasticsearch can go down and forget data, or, you know, burn up in a tire fire, as Kyle says? So the idea is that you keep all the information. You still treat Cassandra as a golden store, basically. And all the metadata that you need to build up in these Elasticsearch documents, you actually keep there. And since we're using time UIDs, you can still do like a query. You can still slice the data, time series data in Cassandra. So that means you can restore. If something happens, we can restore. So let's say the Elasticsearch cluster died, we can bring one new up, and it will start recording all the new data. But then in the background, we can start filling it up again with historical data to kind of come back where we were. So that's another thing. And obviously, you can also, ES has pretty great kind of snapshotting capabilities, so you can snapshot quite often into S3 and then bring it back quickly if something happens. The other thing that's quite interesting is the bottleneck for ingestion now in our platform is how fast we can index document into Elasticsearch now. And it theoretically scales worse for that than when Cassandra does. So we left us, you know, this is our future problem now. How do we scale our mail cluster to write a lot? But there are many other ways around that. You can have separate Elasticsearch clusters for the different things. We also going to slice up like the topic hierarchy that we use for devices, so not everything can see everything else and stuff like that. So definitely workarounds. But I think the benefits really outscale the problems there. Another nice benefit of this is we don't really care about Cassandra anymore. I mean, that could be basically any blob store. So it could be Dynamo, it could be whatever. Another thing we're exploring as well is React. So React has a new thing coming out now, which is called React TS, which is optimized for time series data. So one thing we maybe could do if we move to React is kind of maybe move back some of these bread and butter time series queries from ES to being handled just by React, to find the right balance between all the flexibility and kind of the load. Yes, so that was me. And open sensors. Any questions? I'm dying to get all the hard Cassandra expert questions here.
So what's the main objection about Elasticsearch? The fact that it might lose data, or was there anything else?
Yeah, I mean, that's quite worrisome, right? We obviously want to keep as much data as we can for our customers. And it's actually quite hard to know when you lost data in Elasticsearch. It's no really way to tell it. I mean, all we could do is really compare it to what Cassandra has, but if Cassandra is better. But that's the main thing, that part, and also how does it scale if we go really big.
I work with Solr. I don't know if you thought of using Solr, which is very similar to Elasticsearch, and I never saw it. I never thought of it as a storage for the data, just a search. So I never thought of having data only there.
Yeah.
It surprised me that would be a case.
Yeah, we don't really. I mean, we do store it in Cassandra as well. The point is we don't actually use Cassandra for searches.
Hi. Elasticsearch is probably the cause of 90% of my work-related misery.
There you go.
Just firstly, do you really look at that query where it's filter, bool, should, 3 conditions, and maybe you're putting a magic cache variable in there somewhere, and think that's quite nice? It strikes me as one of those half-implemented common Lisps that we hear about in Cliche. And also, have you had any problems dealing with schemas, in the sense that Elasticsearch seems to have an implicit schema creation thing, and when you give it something that is suspecting an object, whether you give it a string, it's like, I can no longer search. Which has caused several days of manual, painstaking migrations for me.
We're quite careful with the Elasticsearch mappings, which I think is your query there. And we use all kinds of things like the dynamic mappings and template mappings, so we make sure it infers the right type when it's ceasing. I mean, the classic thing is it will do, this is now very Elasticsearch specific, poor you guys, but it infers analyzed on a lot of strings, which you want to filter on, and you can't. So you have to be careful to set up the dynamic templates to make sure you actually it does not analyzed on all those strings. Care has to be taken. But so far, it's pretty good.
Hi. Did you trial or consider InfluxDB for storing time series data?
Influx?
Mm-hmm.
Yeah, I've looked at it. I think, that's the thing that I have they don't even have a JSON syntax, right? They have like a string syntax, kind of like a fixed protocol or something. So the thing is, our payloads can be quite big. So the blobs themselves can be like images. So 100K, kind of the limit. And that was one of the reasons when I scanned over Influx, I kind of moved on, because I don't think it's optimized for pretty payloads of that size. It's more like logs, etc. In my opinion.
So, just wondering why Cassandra in the first place?
Yeah, great. I don't know. I mean, I don't know. It was hip. I don't know. Cool. I mean, we wanted. Yeah, I don't know. I mean, we needed a place to store this time series data, and front page of Cassandra looked nice, and it maybe could do it. And I think Dynamo was a bit too expensive. We thought at that point. So it looks like a reasonable, decision. And I think the thing is, when you adopt one of these data stores, you don't really know what you're getting into until it's too late, because this is like a beast. You have to learn its temperament and how it behaves, right? Yeah. And then the other problem is, once you actually set up the cluster, you've gone through all the chef pane and CloudFormation. And when you've actually done that, you think, do we have to do it again for React now? Like, why don't we just try to make this work until you reach a point where, denial is not an option anymore.
I was wondering, have you considered using Kafka as sort of the canonical data store to populate these databases from? Because I think would fit your model pretty well.
So putting Kafka in between somehow?
Basically as the main canonical data source and populating both Cassandra and Elasticsearch from it.
Yeah, so I mean we have a message broker, right, which we built ourselves. So so it definitely, so this reactor thing can also be a Rabbit cluster if we have to, if we want to go distributed there. The reason why we're not using Kafka is the way MQTT works is quite different from like a core design principle of Kafka. The thing with MQTT is here, you can imagine us having millions of devices here. And typically in MQTT, each device at least one topic. So you would have millions of topics. And so topics is something that's not precious at all in an IoT world. And the problem with Kafka is that the topic is very precious. It's something you set up, you have like a handful of topics, and you have an awesome throughput and everything through them. But if you scale to 1 million Kafka topics, no, it doesn't really work. So that's one of the reasons. Because when we think about message brokers, we really want to kind of solve that problem and actually have our main kind of message broker done that way. So that's one of the reasons I've written it off.
So the PostgreSQL?
There is Postgres as well, yeah. So all the joiny stuff, you know, the CRUD stuff of users and orgs and all that stuff is done in Postgres. But Postgres is not part of the data path at all, which was mainly what I'm talking about here.
It's quite good at taking a lot of data in, but you're talking about restoring your Elasticsearch cluster when you have problems with it.
Yeah.
Do you see any point in the future whereby the rate at which you can get data out of Cassandra won't be fast enough to populate a large Elasticsearch cluster?
That's definitely another problem, right? I mean, the thing we are thinking about it is to partition out our topic tree. So instead of having one big store for everything, it's like some of the orgs will get their own data stores, and that's one of the ways we're going to mitigate that. I told my time is up, but I'm around for lunch, etc. if you have more questions. Thank you.